All right, guys. Hello. Happy first technical month of summer. I hope you enjoyed your 700 years off in COVID. But for your brain and your neurological synapses, we are going to keep learning. And I hope that you watch these videos. And when you walk into 8th grade, Miss Rabbit's going to have absolutely no idea how you know all of this already. Okay? So let's look at what you're expected to know and what I'm going to teach you, because there's no point in me teaching you the entire 8th grade year, then Miss Rabbit has nothing to do. So I'm going to look here what we call the Georgia Standards of Excellence, and we have 8th grade science right here. So I'm going to pull this up, and what I want to show you is all of the things that you're expected to know by the end of 8th grade. You have a full year to learn all this. So we have standard 1 about matter, standard 2 about energy conversions, that they can transform from one to another. We have force, mass, and motion. That's going to be a lot of your physics. Electromagnetic waves and sound. You have already seen the visible light spectrum, so that's going to hopefully be super easy when you get to that. And then lastly, we also have magnetism, gravity, and electricity. So you can see that there's a lot of things that you deal with every day, but they just kind of happen behind the scenes that you're not sure of how. This is going to explain to you why the sky is blue, why things fall the way they do, why gravity is such a rude thing when we're trying to walk, and sometimes Ms. Humphreys falls. We watch that all the time, right? Okay, so I'm going to start from the beginning, and I'm going to give you just a quick introduction to what's called physical science, or physics and chemistry. So today we're going to talk about matter, and the reason I'm starting with matter is because you all sat in my room for however many weeks we got together, and you saw the quote that says, "You have mass, you take up space, you matter." So that was Ms. Humphreys' cute pun for the definition of matter. And yes, it's 8th grade, but I liked it, so I put it in 7th. Let me show you what I'm going to do here. This is a OneNote notebook. Hopefully you're going to get familiar with this over the summer as we work together, and then you can keep your notes organized. And this is also going to stay here, and you'll have an invitation to it so that you can access this anytime during 8th grade. Like, oh, I remember Ms. Humphrey said that. Oh, she's so annoying when she does that dance. I bet it's on this page. And then you'll find it, and it'll be great. So we're on section science. You see we have math and science, because Ms. Humphreys knows what time it is. We will have math sessions on Monday. We're going to start with intro to chemistry, and the very first definition I want to talk about is matter, which I just told you is anything that has mass and takes up space. Well, what is mass then? What does it mean to have mass? So let's talk about mass versus weight real quick, because this is a very common misunderstood thing. You weigh a certain amount, but you have a set mass. When you go on different planets, you are going to weigh different amounts. Your body is not going to lose or gain any mass, but you will weigh more because of gravity. Weight is mass times gravity. And we remember from 6th grade that all the planets don't have the same amount of gravity. When those astronauts are in those ships and they're floating around with 0 gravity, they still have the same amount of mass. Their pants still fit the same way. They still need that belt. They still have the same amount of particles taking up the space. They just don't have the gravity pulling them down. So my mom's joke for this is always that it really shouldn't be Weight Watchers. It should not be Weight Watchers. Oh, Ms. Humphreys could spell. We know she can't. Weight Watchers. It should be Mass Watchers. Because we can't change our gravity, but we can change the mass of our bodies. Now, so we all have mass, we take up space, right? We remember from science that we remember from math that we all have a volume. There's a certain amount of space we take up. Okay, so the volume and the mass of things determine their state of matter. So we know the states of matter. We know what matter is. It's anything that has mass and takes up space. Matter is anything that has mass and takes up space. And we know that weight is mass times gravity. So instead of Weight Watchers, we're Mass Watchers. If we're trying to lose weight, we're trying to decrease the amount of mass that is in our volume. Okay, so volume takes up space. So volume is the amount of space. Delta, thank you so much for having your screen off with your camera off and your mic off. I am recording this lesson, so we are going to pick up, it'll be on the YouTube right where we left off, and you are welcome to ask any questions in the chat. We are introducing chemistry, matter and states of matter. Volume is the amount of space you take up. Okay, so these things, volume, mass, matter, density, these all help us to clarify our states of matter. Let's talk about what they are, and then we will explain which one is each. So hopefully we all remember solid, liquid, and gas. There's this fun new thing for 8th grade and for the rest of your life that does exist. We just didn't tell you about it. If Ms. Humphries could spell it, shocker. Plasma. So we have solid, liquid, and gas. And the things I want you to know about the states of matter and the things that you should know about the states of matter are how those particles are moving and why they are the shape that they are. So if I'm sitting at this table right here, I'm sitting at this table. This table is solid. This table is solid. What if I told you that the particles in this table are moving? They're just vibrating right next to each other. They're kind of just, it's like when you guys are in your seats at school and I tell you to sit down and you're kind of getting like a little shaky and you need to get out of your chair, but you're going to stay in your chair because Ms. Humphries told you to. That's a solid. You're kind of moving around a little bit. You're looking like trying to, where can I go? But you're going to stay there. Okay. So a solid has a set, excuse me, hold on. I took great notes here. Oh, I got it. Come on, Ms. Humphries. Where's the thing where I wrote the set? You watched me write it. That's annoying. Okay. There we go. All right. Sorry, Ms. Humphries blanked. Okay. So set volume and set mass. Volume is the amount of space it takes up. The mass is the amount of stuff that's there. So this solid right here is always going to take up the same amount of room. If I even break down this table, this is still a solid piece. So it has a set mass and a set volume. What that means is that there's always going to be the same amount of stuff, and it's always going to take up the same amount of space. And again, these notes will be here for you all year. You can you can click back on these in like the middle of 8th grade and be like, oh, we're starting chemistry. What did Ms. Humphries say? Whatever. So solid, this has a set mass. It's going to take up the same amount of space and it's going to have the same amount of stuff in it. Now a liquid has a set volume, right? If I fill up a cup of water, I'm gonna prove it to you, hold on. Pause for proof. Okay. A liquid has a set amount of volume. It takes up the same amount of space in the world, right? This water is not going to go anywhere, but I can change the world in which it takes up. I can change its mass, but I can't change its volume. So it never is going to change the amount that's there. Does that make sense? But you can change its shape. So we have a set volume, unset mass, and gas. So if I heat this water up to boiling, we're going to start evaporating the liquid off. So all of this isn't going to evaporate at the same time. So we're not going to keep a consistent volume because it's going to change as it heats up. So we're not going to end up consistently, like I transferred from one cup to the other. I can't instantaneously easily make this all evaporate. So it's going to change the amount that's in here, and it's also going to change the amount of space that it takes up in the atmosphere. So gas has no set mass or volume. No set mass or volume. So you see we get from a solid, which is very specifically set, to a gas, which is just merely floating around. And there's our liquid in between. Now plasma is probably the new thing that's introduced to you. And plasma is literally just balls of electricity. You find these in lightning. Ooh, electricity, lightning. And the other thing my mom told me about that I super remember. Okay, lightning. So plasma are balls of energy, and those are going to just be an enormous amount of electrons waiting to charge and then have some kind of reaction. So plasma definitely has no set mass or volume. So what does mass and volume help us? Why do we care about mass and volume? Well, let's talk about density. Density is going to be one of, in the words of my mother, who was taught 8th grade, I have not, density is the hardest definition for anyone to remember. But I think kids as smart as you are definitely going to understand that it's just division, and it makes sense to have a higher number in the numerator than denominator when we're dividing. So let's do a very real example, okay? So the mass is the amount of stuff you have. The volume is the space you take, okay? So let's think about this very simplistically, okay? Ms. Humphries is only 5'6", okay? That equals a total of 56 inches, right? 66? 66 inches. 66 inches. And we're gonna lie before Corona and say Ms. Humphries is 175. Before Corona, don't talk about it. So I'm gonna take my mass, which is 175 pounds, and I'm gonna divide it by my volume, which is how much space I take up in this world, of 66 inches. And I'm gonna get my density. So let's actually do that. 175 divided by 66. 175 divided by 66 is going to be 2.65. So for every inch, I have 2.65 pounds per inch. Now, I have a friend who is 6'8", okay? So this man is gigantically tall. So 6'8" is 80 inches. He's probably chilling at like a good 150. 200. 240? 240, okay. 240 is what I definitely knew all on my own. So we're gonna do the exact same equation. We're gonna do 6'8", which is 80 inches, divided, or excuse me, his 240 pounds of body mass divided by his 80 inches that he spreads. He has a density of 3 pounds per inch. So if you look at that, it says that he looks taller and skinnier in real life. But if you look at the density, he is denser. This is why a lot of people say that muscle weighs more. Muscle is denser. It is a higher mass with a lower volume. A piece of muscle takes up about this much space and has 5 pounds. So its mass is still the same, but its volume is substantially smaller than fat. 5 pounds of fat and 5 pounds of muscle is still the same mass. It's the volume that takes up that's going to change your density. Okay, so let's do something if it has the same mass. Let's say 5 pounds of fat. 5 pounds of fat takes up, let's say, we're just throwing it out there because we know that fat takes up more room. Let's say 5 pounds of fat takes up, I don't know, 2 feet. So let's say 24 inches. Well, what if 5 pounds of fat takes up only 12 inches? Let's see which piece is denser. Does not weigh more, it's denser. Very specific. Weight, you're immediately talking about gravity. I'm not talking about gravity here. I'm talking about how much stuff is in a space. So 5 divided by 24 is 0.20. 5 divided by 12 is 0.41. Heck yeah, we are double the density. Muscle is, in this fake made up example, is twice as dense. So you notice if you change one of those variables, either your numerator or your denominator, either your mass or your volume, you're going to change your density. Density is the amount of stuff impacted into a room. So if Miss Atkinson and I's room is the same size, but I have 47 kids in my room and she has 28 kids in her room, my room is denser. Same volume, more mass. All right, I hope that makes sense. That is mass, volume, density, mass versus weight, states of matter. Okay, I'm going to link these 2 other videos into the YouTube link so you can watch those if you are really super interested in mass. Let me take you back to our 8th grade standard and show you what we've talked about so far. So we have defined matter. We're done with that. Here, let me actually pull this up. I think that's gonna help. Okay, we've defined matter, check. I have a really cool experiment that I want to do for element compound mixtures, heterogeneous, homogeneous, and I'm not home right now. So I'm going to save that for next week because I want to do some very cool non-Newtonian solutions. We have talked about particles in solids and the way they move. We know that solids have set shape and volume, liquids have set volume but not shape, gas has neither set volume nor shape, and plasma are balls of light. Oh, there we go, stars. Ms. Humphreys found her notes. Isn't that lovely? All right, then we have properties of matter. Again, this is going to be a super cool activity where we get to boil stuff, melt stuff, combust stuff, and I want to be able to do all of that with you at home. So we are not talking about that right now. Defining and defending chemical and physical changes. Those are going to be baking cakes, changing water into gas and back into solids. And so again, those are really cooler experiments I want to show you at home. And atomic modeling, I'm going to tell you now, is not fun. It's just not cute. I don't like it. I'm sure my mom will find a fun way for us to learn it, but that's just the honesty, guys. Chemistry is not that fun. So last thing, balancing chemical equations to prove the conservation of matter. This is the last topic I want to talk to you about, the conservation of matter for today. And then we will dive into chemical equations, if I am still not home, next week. Ms. Humphreys is just kind of doing whatever right now. So conservation of matter. Let's talk about, oh, not my email. Let's talk about things being created nor destroyed. So matter. Okay, so hopefully you guys remember in class, some of the classes got to do this inside, some did it outside, but we stood on one side and I had you guys run to the other, and I just kind of played tag where I grabbed you and you had to remove yourself from the situation until we were left with only so much, the energy transfer. Well, remember, you didn't die. We brought you back in each time. You were lost as thermal energy. So the important thing that you need to know about matter, energy, mass, all of it, is it can neither be created nor destroyed. So what does that mean? You can't make it, can't break it. Now, Ms. Humphreys' favorite part of the scientific experiment, or the scientific law that we've proven, is that U is the process of stellar nucleosynthesis. So because nothing in nature, nothing in this world from the Big Bang to the end has ever been created nor destroyed, you technically, sweet starshines at 13 years old in the year 2020, are made of stardust. You are made of sunshine and stars. You are balls of plasma. So the Big Bang started, we had balls of molecules slam into each other at such a rate that it started to expand. We've proven that the universe is continuing to expand with blue and red light rays. You're able to literally watch the waves pull themselves apart and expand. The universe is continuing to expand, and all of these molecules are constantly rearranging themselves. So I'm going to take this water, I'm going to drink it. It's going to go into my mitochondria. It's going to meet with the glucose of the donuts I ate earlier. That sugar and that water is going to meet in my mitochondria, perform cellular respiration. Then you watch those chemical equations. We played with the marshmallows. You watched an exothermic reaction. You saw we had the same amount of marshmallows left than we did when we started with. All we did was rearrange these two hydrogen and one oxygens, to be a hydrogen and two oxygens. All I did was separate this in my body. So you are never losing chemicals, you're rearranging them. So we can never lose nor generate energy or matter, which means that all the stars that have ever been made were made of the same molecules that are here. So my cup, technically, is made of stars, and my phone, and everything. If you ever think about it, you ever wonder why the world doesn't get heavier because we keep building stuff on it? Because everything we've built with was already here. We're rearranging molecules and particles to make new things. We don't make new molecules and particles. So conservation of energy is super, super important. Conservation of matter and conservation of energy. Those are different things, because energy can neither be created nor destroyed. It's going to be always released as thermal energy. So that's a super important concept to understand conservation. conservation will be vital, and we will do some chemical equation examples probably next week, or I'll post an example tutorial on here if you really want to dive into those. And then hopefully I will be home or somewhere with a kitchen I understand, and we will do some properties of matter and some chemical physical changes. So that is introduction to chemistry. Remember, this is 1/5 of your 8th grade material, and we have learned 1/5 of that 1/5. So you have officially learned in 20 minutes a 25th of your 8th grade science content curriculum. So very good job, guys. Please post any questions down below in the comments. Check out the links that are posted. Obviously, always like and subscribe. See you next week.